हेलो, गुड मॉर्निंग स्टूडेंट्स। आज हम लोग यूनिट 4 डिस्कशन करेंगे। यूनिट 4 के जो टॉपिक्स हैं जो आज कवर करेंगे वो है टॉर्जन, सर्कुलर, सॉलिड एंड हॉलो शाफ्ट्स। ओके। और इस यूनिट में और टॉपिक्स हैं, जो अदर टॉपिक्स हैं वो है टॉर्जन, मूवमेंट ऑफ रेजिस्टेंस, पावर ट्रांसमिशन ऑफ स्ट्रेट एंड स्टेप शाफ्ट्स, स्विफ्ट ट्विस्ट इन शाफ्ट सेक्शंस, थिन ट्यूबुलर सेक्शंस, थिन वॉल सेक्शंस एंड सेकेंड पार्ट है इसमें कॉलम्स। वो डिस्कस करेंगे आगे फर्दर। हम लोग आज डिस्कस कर रहे हैं टॉर्जन इन शाफ्ट्स। टॉर्जन इन सर्कुलर solid shaft. Let us consider a circular shaft of diameter d and length L, having a torque T and the modulus of rigidity of the shaft is G. Okay. Now a shaft is said to be in torsion when equal and opposite torques are applied at the two ends of the shafts. The torque is equal to the product of the force applied and radius of the shaft, as we know that. Due to the application of the torques at the two ends, the shaft is subjected to the twisting movements. This causes shear stresses and shear strains in the material of the shaft. देखिए, जब भी एक टॉर्क, जो शाफ्ट्स होती हैं बेसिकली वो पावर ट्रांसमिशन के लिए यूज़ की जाती हैं, और पावर ट्रांसमिशन में जब भी टॉर्क अप्लाई होता है किसी शाफ्ट पर, तो टॉर्क अप्लाई करने से सेक्शंस में shear स्ट्रेसेस डेवलप होते हैं। ठीक है, shear स्ट्रेसेस और shear स्ट्रेंस डेवलप होते हैं ड्यू टू दी टॉर्क अप्लाइड ऑन दी शाफ्ट। क्लियर? कुछ एजम्पशंस हैं जो हम लोग टॉर्जन डिस्कशन, जब हम टॉर्क का shear स्ट्रेस का कैलकुलेट करते हैं या स्टडी करते हैं किसी सर्कुलर शाफ्ट का, तो कुछ एजम्पशंस हैं जो हमें एज्यूम करना होता है, जिसमें पहला एजम्पशन है कि जो मटेरियल है पूरे शाफ्ट का वो होमोजीनियस है, होमोजीनियस मटेरियल है। दूसरा आइसोट्रोपिक है। नेक्स्ट, जो प्लेन है, क्रॉस सेक्शन है जो भी प्लेन इसका शाफ्ट का, वो आफ्टर दी टॉर्क अप्लाई करने के बाद भी प्लेन ही रहेगा। ठीक है, बिफोर द अप्लाइंग द टॉर्क सेक्शन, क्रॉस सेक्शन प्लेन है और उसके बाद भी वो प्लेन है। ठीक है, और जो इलास्टिक कांस्टेंट है, जो इलास्टिक प्रॉपर्टी है वो भी कांस्टेंट है। ठीक है, जी। अब हेलो जी, तो एज्यूम करते हैं, कुछ चीज़ें कंसीडर कर लेते हैं। लेट लेट capital R is the radius of the shaft, radius of shaft, L is the length of the shaft, length of shaft, capital T is the applied, torque applied, small shear stress, tau is the shear stress capital G is the modulus of rigidity. Modulus of rigidity. So rigidity and टॉर्क अप्लाई करने से पहले सेंटर पॉइंट ओ है शाफ्ट का क्रॉस सेक्शन का, इसके रिस्पेक्ट में एक पॉइंट हमने लिया ए. आफ्टर अप्लाइंग द टॉर्क दिस पॉइंट इज ट्रांसफर टू द पॉइंट बी. नाउ angle AOB is theta. This angle is known as angle of twist. This angle is known as angle of twist. Theta is angle of twist. Okay, clear? And this angle, सरफेस पे जो एंगल बना रहा है सरफेस पर, उसे कहते हैं फाई. इसे हम कहते हैं सॉलिड एंगल और shear strain. This will be the shear strain in the shaft due to the torque T. यहाँ पर एक टॉर्जन इक्वेशन होती है जिसकी हेल्प से हम लोग shear स्ट्रेस और टॉर्क जो अप्लाई कर रहे हैं उसमें हम एक रिलेशन फाइंड आउट करते हैं और shear स्ट्रेस कैलकुलेट कर सकते हैं. उसे टॉर्जन इक्वेशन कहते हैं. तो टॉर्जन इक्वेशन का डेरिवेशन अभी हम लोग करते हैं कि किस तरीके से shear स्ट्रेसेस वेरी करते हैं शाफ्ट में. ठीक है, क्लियर? अब हाँ, सबसे पहले फर्स्ट ऑफ ऑल ये हमारी शाफ्ट है और ये सर्कुलर सेक्शन क्रॉस सेक्शन इसका सेंटर पॉइंट ओ था, पहले पॉइंट ए पर था एक, ये पॉइंट ए से शिफ्ट हो गया बी पर. ये है एंगल ऑफ ट्विस्ट थीटा. यहाँ पर शाफ्ट की लेंथ थी एल. सरफेस पे जो पॉइंट हमने सेंटर लाइन से ड्रॉ किया, ये पॉइंट हम मान लेते हैं डी. दिस इज द पॉइंट ए. ये ए पॉइंट होगा हमारा रेफरेंस सिमिलर. और जो शिफ्ट हो गया दिस विल बी द पॉइंट बी. डी पॉइंट को बी पॉइंट से मिलाएंगे. दिस विल बी द shear strain phi. Now distortion at the outer surface due to length, due to torque T. कितना डिस्टॉर्शन हुआ, डिस्प्लेसमेंट हुआ, इट इज इक्वल टू द ए बी. ओके, ए बी. और इस ए बी की लेंथ अगर हम फाइंड आउट करना चाहें तो ये होगा आर्क एंगल ऑफ ट्विस्ट मल्टीप्लाइड बाय रेडियस द आर्क. ओके. shear strain at the outer surface, shear strain at outer surface will be equal to the distortion divided by length of the shaft. As we know that shear strain के केस में अगर कोई पैरेलल फोर्स अप्लाई किया जा रहा है और ये डेल्टा एल शिफ्ट हो गया, this is the initial length L, then in that case shear strain phi is equal to the delta L upon L, distortion upon initial length. So here shear strain phi will be equal to the AB upon L. AB upon L. Now, distortion AB will be equal to the radius of the arc multiplied by angle r theta. Substituting the value of AB, the value of AB in above equation, phi will be equal to the r theta into L. Okay, r theta into L. We know that we know that according to the Hooke's law, shear stress is equal to the modulus of rigidity into strain. So phi will be is equal to, from here, phi will be is equal to the shear stress upon modulus of rigidity. Replacing this value, tau upon r, tau upon g will be equal to the r into theta by L, or tau by r equal to the g into theta by L, where tau is the shear stress at the radius r, capital G is the modulus of rigidity, theta is the angle of twist, and L is the length of the shaft. This is the equation number 1. Clear? Now, from here, shear stress tau will be is equal to the r into g into theta by L. Here, modulus of rigidity, angle of twist, and length is constant. So, the shear stress is directly proportional to the radius. Okay. Now, maximum torque transmitted by a circular shaft. Now, let us consider a strip of radius small r at radius small r of thickness dr. Okay. Now shear stress on this force on this force on the strip df will be equal to the area of the strip multiplied by stress. Now, the area of the strip is 2 pi r into dr, and the shear stress tau. Now, torque on strip will be equal to the force into radius. Total torque on the total torque on shaft, it will be equal to the dt integration 0 to r df dr. Okay, torque T will be equal to this integration 0 to r 2 pi r into tau dr into r. It means r square. Okay, df 2 pi r square tau. We know that tau will be equal to the T is equal to the 0 to r 2 pi r square. Tau is small r into g into theta by l dr. So T will be equal to the 2 pi g into theta by l integration 0 to r cube dr. Okay, T will be is equal to 2 pi, इसे हम बिना ही रिप्लेस किए भी अब हम लोग सॉल्व कर सकते हैं. इस वैल्यू को टाउ ही रखते हैं. ठीक है, नो नीड टू चेंज. जो पार्ट कॉमन होगा वो होगा 2 पाई टाउ, ये होगा आर स्क्वायर 2 पाई टाउ आर क्यूब बाई 3. 2 pi g into theta by l r to the power 4 by 4. Okay, T will be is equal to the 2 pi g into theta by l r to the r is equal to the d by 2. So it will be equal to the d to the power 4 upon 16 into 4. Okay, or T will be equal to the pi d to the power 4 upon 32 into g into theta by l. Pi d to the power 4 upon 32 is the polar moment of inertia. It will be equal to T by j g into theta by l. Here j is the polar moment of inertia, which is equal to the pi d to the power 4 upon 32. Polar moment of inertia meaning moment of inertia, second moment of inertia of the section about its axis which is perpendicular to the section. मान लेते हैं कि ये x एक्सिस है, ये y एक्सिस है और z एक्सिस is perpendicular to the cross section. So here moment of inertia about the z action is equal to the ixx plus iyy. This is the perpendicular axis theorem. As we know that the moment of inertia of the cross section about about a axis, an axis which is passing from its center will be equal to the pi d to the power 4 upon 64, pi d to the power 4 upon 64. So the moment of inertia about the x-axis and y-axis are equal to each other because the section is symmetrical. So moment of inertia about the y-axis is also equal to the pi d to the power 4 upon 64. Now the moment of inertia about the z-axis will be equal to the pi d to the power 4 upon 32, which is known as polar moment of inertia. It is generally denoted by the j. Okay, now the total, now from here we get the torsional equation, which is T by J is equal to tau by R into G into theta by L. Now, this equation this equation is known as torsional equation. This equation is known as torsional equation. Clear? Now, एक क्वेश्चन एक न्यूमेरिकल सॉल्व करते हैं इस पे सिंपल. A solid shaft of 150 mm diameter given. Diameter of shaft, meter of shaft, D will be equal to the 150 mm, is used to transmit torque. Find the maximum torque transmitted by the shaft if the shear stress induced to the shaft is 45 Newton per mm square. Maximum allowable shear stress tau will be is equal to the 45 Newton per mm square. So find out the maximum torque. Let T will be equal to the maximum torque transmitted by the shaft. Maximum torque transmitted by shaft. Okay. Now from the torsion equation, T by J will be is equal to the tau by R. As we know that maximum shear stress will occur at the outer surface of the shaft because shear stress is directly proportional to the radius of the shaft. Okay. So the shear stress at the center of the shaft will be 0. As we move towards the outer surface, the shear stress will uh, maximum at the outer surface of the shaft. Where so outer at outer surface shear stress will be maximum. Okay. So at R is equal to 150 mm, tau will be 45 Newton per mm square. Now the polar moment of inertia J will be is equal to the pi d to the power 4 upon 32. Here 150 is the diameter of the shaft. So the radius of the shaft will be 75 mm. Okay. Now polar moment of inertia is known as J is equal to the pi d to the power 4 upon 32. Now calculating this polar moment of inertia, here diameter of the shaft is 150 mm. So the polar moment of inertia will be 150. It will be equal to 497,00977.52 mm to the power 4. Okay. Now putting this value in Torsion equation, the T will be equal to the 497,00977 equal to the shear stress is 45 and the radius is 75. So the maximum torque T will be equal to the 29820,586 Newton mm or 29820.586 Newton meters. It will be the maximum torque can be transmitted by the shaft. Okay. Now come to the hollow circular shaft. Torque transmitted by a hollow circular shaft. Let RO is the outer radius of shaft. Outer radius of shaft. RI is the inner radius of shaft. Capital T is the torque transmitted by shaft. G is the modulus of rigidity of shaft. Okay. And small r is the radius of elementary ring. Dr is the thickness of ring. Tau is the maximum shear stress. This maximum shear stress occurs at the outer surface of the shaft. Okay, and tau r is the stress, shear stress induced on elementary ring. Okay, the outer radius of the shaft is RO, inner radius of the shaft is Ri. Okay, small r is the radius of elementary ring and dr is the thickness of the elementary ring. Now, shear stress at the elementary ring is obtained from the equation tau upon Rho will be is equal to tau r upon small r, or say shear stress at the ring will be equal to the tau upon Rho into small r. Turning force on the ring, force on ring dF will be equal to the area into stress. Area will be equal to the 2 pi r into dr, and the stress will be equal to the tau r naught upon r naught into r small r. Now dF will be equal to the 2 pi r square dr tau upon r naught. Okay, this is the force on elementary ring. Now the turning moment on the ring, on ring dt will be equal to the force into radius small r. So dt will be equal to the 2 pi r cube dr tau upon r naught. Okay, the total turning moment on the shaft, total turning moment on shaft will be equal to the integration dt ri to ro. Okay, now integrate the above equation, integration ri to ro 2 pi r cube dr tau upon r naught. Okay, so from here t will be equal to the 2 pi tau r naught integration ri to ro r cube dr. T will be equal to the 2 pi tau r naught r keep r to the power 4 by 4 ri to ro, or T will be equal to the 2 pi tau upon ro to the power 4 minus ri to the power 4 by 4. Let do is the outer diameter of the shaft, of shaft, and di is the inner diameter of the shaft. It is equal to the 2 ro, and this is 2 ri. Okay, now from here outer radius will be equal to the diameter of the shaft divided by 2. Ri will be equal to diameter of inner diameter of the shaft divided by 2. Now putting these value in the above equation, T will be equal to the 2 pi tau upon r naught replaces by d naught by 2 within bracket d naught by 2 to the power 4 minus minus d outer to the power d outer by 2 power 4 d inner to the power d inner by 2 to the power 4 divided by 4. Okay. Now T will be equal to the pi by 2 shear stress tau within bracket d outer to the power 4 minus d inner to the power 4 upon 16 into 2 upon d outer to the power 2 divided by d diameter of outer surface. Okay. From here pi by 32, yes, pi by 32 d outer to the power 4 minus d inner to the power 4 multiplied by tau upon diameter of outer surface. Okay, multiplied by 4 is also is here 2. Okay, now from here this is the polar moment of inertia of hollow circular shaft. So T is equal to J into tau upon diameter of it will be equal to the radius of this will be diameter and it can be changed in the radius. Okay, so T by J will be equal to the tau upon R naught, where J is the polar moment of inertia of the hollow circular shaft, pi by 32 d outer to the power 4 minus d inner to the power 4. Now power transmitted by the shaft, power transmitted by the shaft. Let capital N is the RPM of the shaft, capital T is the torque transmitted in Newton meters. Omega is the angular velocity of shaft in radian per second. So the power transmitted will be equal to the 2 pi n into T by 60 in watts, or we can write this power is equal to omega into T, where omega is equal to the 2 pi n by 60 in radian per seconds. Is it clear? So for a solid circular shaft or a hollow circular shaft, torsion equation will be T by J is equal to tau by R is equal to G into theta by L, where T is the maximum torque transmitted by the shaft, J is the polar moment of inertia. For solid circular shaft, the polar moment of inertia is pi d to the power 4 by 32, and for hollow circular shaft it will be equal to the pi by 32 diameter of outer circle minus diameter of inner circle to the power 4. This will be the polar moment of inertia. Tau is the torque induced at a radius of a ring of radius r. Capital G is the modulus of rigidity of the shaft. Theta is the angle of twist and L is the length of the shaft. Okay. By this formula we can calculate the shear stress on different rings due to the torque applied on the shaft. Okay. Now in a hollow circular shaft, outer and inner diameter of 20 centimeter and 10 centimeter. Outer diameter DO is equal to the 20 centimeter or 200 mm. Inner diameter DI is equal to the 10 centimeter or 100 mm. Maximum shear stress in a hollow circular shaft of outer and inner diameter of 20 centimeter and 10 centimeter respectively, the shear stress is not exceed 40 Newton per mm square. The maximum shear stress is given is equal to the 40 Newton per mm square. Find the maximum torque which the shaft can safely transmit. Let capital T is the torque transmitted by the shaft. Is it clear? Now, polar moment of inertia of the section J will be is equal to the pi by 32 diameter of outer circle minus to the power 4 minus diameter of inner circle to the power 4. Clear? It will be equal to the pi by 32 200 to the power 4 minus 100 to the power 4 by nothing. So this will be the polar moment of inertia. Calculating the value of t minus 1 t y, it will be equal to the J will be is equal to the 1.472621 into 10 to the power 8 mm to the power 4. Okay. So maximum torque capital T will be equal to T by J tau into RO. So from here capital T will be is equal to the maximum shear stress is 40, J will be 1.472621 into 10 to the power 8 divided by outer radius is 100 mm. So the maximum torque can be transmitted will be equal to the 58904860 Newton mm, or 58904.86 Newton meter. This will be the maximum torque transmitted by the shaft safely. Okay, thank you very much.